Hey students, this is lesson 2.4. In this lesson we're going to learn how to solve equations with variables on both sides. Go ahead and do the review and I'll check back with you. So any equation that is always true is an identity. Keep that in mind as we do the lesson today. So the first one here, what is the solution of 5s plus 13 equals 2s plus 22? Now the object of this equations like this is to make it a simpler equation where you only have s in one spot. And we're going to use the properties of equality to do that, usually the subtraction or addition properties of equality. In this first one, if I take away 2s from this side, I get 0 plus 22, which is just 22. And if I take away the same thing on the other side, then I'm using the subtraction property of equality, and we should be okay. So I end up with 3s plus 13 equals 22 by doing that step. So just use the subtraction property of equality. And now I can just work backwards. I'm going to subtract 13 from both sides, so I get 3s equals 9. And then divide by 3, I get s equals 3. So I use some more properties of equality there. Now let's just check it. Since we have variables on both sides, we better do that. So I think s is 3, so that means 5 times 3 plus 13 should equal 2 times 3 plus 22. And so this is 15 plus 13 is 28. And this is 6 plus 22, which is also 28. So it does check. All right, you try that. All right, sometimes we want to solve an equation that has variables on both sides. It says Laurel pays someone $35 to clear a driveway when it snows. She wants to buy an electric snowblower for $689 so that she can clear her own driveway. If the area Laurel lives in has an average of 5.2 snowfalls per season, how many seasons will it take her to break even on what she spends for the snowblower? I'm not really sure this problem models what we're trying to model here, so I might go through the next one with you. Actually, I'll do that. I'll leave this one for you to figure out, and I'll work you through this one. So an office manager spent $650 on a new energy-saving copier that will reduce the monthly electric bill for the office from $112 to $88. And how many months will the copier pay for itself? So here's the model. The cost of the copier plus the new monthly cost. The new monthly cost is the lower price, 88, times the number of months is equal to the old monthly cost times the number of months. So if you didn't change it at all. So, and we're going to use M to represent the number of months. And so 650 plus 88M equals the old monthly cost, which was 112 times the number of months again, M. So we have the equation 650 plus 88M equals 112M. And to solve this, we're going to subtract 88M from both sides. And that gives us 650 plus 0 on this side, which is 650. And 112 minus 88 is 24M. So we're going to take 650 divided by 24 to get our answer. And 650 divided by 24 equals a little bit over 27. So we can say that the copier will pay for it in about 27 months. All right, go ahead and do this top problem and see if you can get the right answer. And I'll check back and show you how I did it. All right, sometimes you we'll have some grouping symbols to deal with, and you can deal with them a couple ways, just like we did in the last lesson. But one way would just be to go ahead and use the distributive property right away, get rid of those parentheses. So then I would get 2 times 3x is 6x, 2 times 1 is 2. Then I get 4 times x is 4x, 4 times 5 is 20. Then try and get both the variables on one side. To do that, you could subtract 4x from both sides, so use the subtraction property of equality. That gives you 2x plus 2, and this is actually a negative 20. Subtract 2 from both sides, and you get 2x equals negative 22, and then you get x equals negative 11, because 2 times negative 11 is equal to negative 22. Now that one you should probably check, because we're not quite sure that we did it all right, because we did a lot of steps there. So we want to make sure that if we substitute negative 11 in there for x in there, that they're equal. And this is 2 times negative 33, which is negative 66, plus 1 is negative 65. And hopefully that equals the other side. Negative 11 minus 5 is negative 16. Multiply that by 4, we get negative 64. And we see that it isn't quite the right answer, so we better check what we're doing here. And it's just a little simple problem here. I put the parentheses in the wrong spot there. So I should have done negative 33, get rid of that one, plus 1 first, and that's negative 32 times 2 is negative 64. So that's check out. All right. It's good to check your work. Go ahead, you try this problem. All right, identities and equations with no solutions. Let's check this one out here and just see what happens when I go through the steps of solving it. So let's start by simplifying this side. So we get t plus 8 equals negative 1t plus 2t is 1t plus 6. And just look at that closely and just think about that. So you have some number t, you add 8, and you want to make that equal that same number t plus 6. I just don't think it's going to work out. But look what happens when we subtract t from both sides here. We then get 8 equals 6, which is false. And when you end up solving the equation, you end up with something like that. There is no solution to that equation. It's an impossible equation. All right, now let's check this next one out. So we have 6r. I'm going to distribute here. 7 times r minus 7 times 3. And over here, I'm just going to write down what we have. And now I'm going to just simplify both sides. 6r and 7r, I can combine like terms there and get 13r. And on this other side, if I take 7 minus 28, that's a minus 21. So I get exactly the same thing on both sides. Now look what happens if I keep solving this. I subtract 13r from both sides. I get negative 21 equals negative 21, which is true. When you have that, that means any number will work. We call that an identity equation. So basically what you have is that side is equal to that side, so it doesn't matter what variable is, any number will work. All right, I'm going to let you try that. Okay, so another example of an identity equation. All right, here's a concept summary you can use. So if you follow these steps, you should be successful most of the time solving your equation. Always remember to check your solution. Go ahead and do the lesson check and be ready to share that in class. I'll see you later.